First thing, I wasn't here last year. I think there was some Swedish guy from the Squid project here last year. Okay. Today I'm going to talk about Varnish and why I think it's a very important thing for you to have in your front-end stack. I'm going to talk mostly about the feature I like the most about Varnish. Usually, until now, when we've been talking about Varnish, we've been talking a lot about its speed. And speed is nice, but one thing is so much cooler is its flexibility. Okay, so first a bit of definition. This is just what I'm going to talk about. So in every HTTP transaction, we have a client and we have a server. And Varnish is installed in between the client and the server. And we look upon ourselves as some sort of extension to the server. This is important for those of you who read RFCs. Because we get some flack because we do break some of the RFCs. Some of the RFCs specify how a cache should behave, and we ignore those because we are actually not a cache in the way the Internet Engineering Task Force defines a cache. Because we're not public, we are under the same control, under the control of the same people that control the web server, which is an important distinction. So we're not just caching any random content that comes along, we're caching what you actually want it to cache. Okay, a bit of history first. Started with this guy, Anders. He had an idea in 2005. 2005 in web caching history was some sort of a low point. In the beginning of the millennium, there was quite a lot of attention around web caching. People were talking about it. There were lots of products dealing with web caching. And after the dot-com bubble burst, interest seemed to fade. And in 2005, it wasn't really any good. VG, which is more or less Aftonbladet in Norway, had at that point, I think they were running Squid on 12 servers. My impression of the Squid project at that time was that they were first and foremost focusing on being a forward proxy. A forward proxy is a kind of a proxy which you install in your office, so that if one of you goes to Aftonbladet and has a look at the front page, and your neighbor does the same thing, it'll be served locally from the cache instead of being fetched over the internet. It was very relevant in the times of ISDN lines. So VG had, at that time, they were running Squid on these 12 servers, and some back-of-a-napkin calculations show that it shouldn't really use 12 servers to serve 1 gigabit of traffic. We should really just be using 1 or 2. And so Anders made contact with a couple of people, and the Varnish project was initiated. We had a 1.0 release in 2006, and then we had in 2008, we had the 2.0 release. This was the first release that we actually recommend that you run if your host name was different from vg.no. Usually it was very specifically written to VG. I know some brave souls actually managed to make it run on other sites as well. There's a 3.0 release just around the corner. On the 16th of June, we'll be releasing the 3.0 version of Varnish. I'm going to talk a bit about that later as well. Okay, feature overview. We're open source. It's distributed under a friendly too-close BSD license. Basically, that means that you can do whatever you want with it. There's 2 things you can't do. You can't strip away the copyright headers from the source, and you can't sue me. Well, you can try. Kind of the first thing is speed. The first feature, and I mean, Varnish has got the speed. When you do lab tests, we managed to push a cheap server and push 250,000 HTTP transactions out of it. Now, this is a synthetic benchmark, so of course it's not really useful to anything. We've seen real live traffic reach 60,000 transactions per second. Basically, that's enough for most of us here up in the north, because we don't really have that many people. So most websites are actually, if they're properly configured, should be able to run on one server. Another aspect of speed. This is, we migrated some somewhat trashy Norwegian website from, I think they were actually running 14 servers. They were also running Squid. And I need to stress that I'm not trying to really badmouth Squid. A lot of, probably they weren't very good at tuning Squid. I mean, I'm absolutely sure that Squid could perform a lot better when tuned, but this was what it was when we came there. So we had 14 servers here running Squid. We installed 2 servers running Varnish, and we switched there. You can, yeah, it's quite obvious that the speed went up. And this is why speed matters. This is a graph which is made by the CTO of Wikia, another Swedish guy actually, Arthur Bergman. He made some experiments on Wikia. Wikia is sort of the commercial sister organization of Wikipedia. You have all sorts of different wikis there. You have my favorite, the Star Wars wiki, which is called Wikipedia. And he was playing around with the response time of his web infrastructure. So inducing more and more delays and see how that affects traffic. And at the bottom here, the page would load more or less immediately, and 7.5% of the users would be lost and would not click on another link. Now, if we go and see if there's a page load time at approximately 1 second, you see that that's probably around 11–12%. And at 2 seconds, we're at probably 17%. So this is why speed actually is important. Not just for the actual business part of it. Okay, so now I'm trying to approach the thing which I think is really, really cool. One thing that Varnish does is, instead of having this typical configuration of any program, where you have key value in some sort of ini or config file, in Varnish you write little programs. And those programs get translated into machine code, loaded and executed. This gives you 2 distinct advantages. One is that it makes things go faster, because your code will, and it makes also the code a bit more readable, because the code will not look like if this directive is set, do this. If this directive is set, do that. The other thing is that it makes it possible to create actual policies, which means that you can, for this kind of a transaction, do this and then do this, which is really, really hard to express in a key value style configuration file or a markup XML style configuration file. It's more or less impossible. I'll come back to this, and I'll be talking a lot more about this. Now, Varnish was not written by, but ordered by a bunch of system administrators. And so, in online media, the most critical thing, and I've been actually running websites for 10 years, media websites for 10 years, was to always be able to serve some content. Serving stack traces isn't particularly popular when you're serving to the mass public. So a critical feature of Varnish was to be able to save the request and to actually serve some more or less relevant content even if something fails. This means that if you have to retry the transaction, if you have to rewrite the transaction or reroute it, we have to be able to do that. Now, next feature is Varnish has a built-in load balancer. It's quite really a small feature, but I'm kind of taking it with me as well because it combined with the flexibility, it can really do great things. So the load balancer is really okay. It has health probes, sticky sessions, everything. And so, oh, there's a point missing there. Up here, there's supposed to be a 1, and where we try to actually fetch the request. I mean, if you have a client asking for the front page of Aftonbladet again, and they're asking some application server, and that server fails. So in Varnish, you could then sort of implement a policy where you, okay, that failed, so we try another app server. And maybe that fails as well. Maybe there's something wrong with the database or something. So then we sort of rewrite the request. We add a try harder equals 1 to the request, and then we send it to another request, another app server. And if that fails as well, we try to find some old content in the cache that matches the URL. Serving old content isn't perfect, but it's way better than serving error messages or stack traces. If that fails, we can serve an error. Of course, we can write these policies as long as we want to. But, I mean, if you have a look at this, because most of you are programmers, and you try to express this in a key value language, or XML. I've actually seen people doing exceptions in XML. Well, that was there in the edge side include languages. There are exceptions in XML, and it's really not pretty. So it's theoretically possible to do, but it's really horrible. And so this is really why I think Varnish is the greatest thing since sliced bread. Any questions to that? I mean, if you have an actually relevant question, please feel free to interrupt. If you have a completely irrelevant question, I would take those at the end. Oh, there it is. So Varnish is what I call fully programmable, and it can do awesome tricks. The first trick here is I found a blog post that was back in 2006. It was 1 month after the first release. Somebody made a blog post with how to avoid hot linking. Now, of course, who here knows what hot linking is? Okay, roughly half of you knows what hot linking is. So I'll give you a very brief explanation of what hot linking is. So let's say that me and Ragnar, I have a blog and he has a blog. Now, I write really inspired articles sometimes, and I also take awesome pictures. So I make this blog post with a picture on it. Ragnar here makes a really tabloid version of the same blog post, rips my picture off from that post just by linking or just by using in the IMG tag, just referring to my server. Now, since his blog is much more tabloid than mine, he gets approximately 100 times more traffic. Now, I end up paying for that bandwidth because the pictures on his blog are fetched directly from mine. And I really want to avoid that. So that's hot linking. And this code came up approximately 1 month after the first release. Now, it's more or less intuitive. I mean, we can just sort of ignore most of it. But I mean, we do see here that we check on the request for the host header, if the host header is example, and then we check if the URL matches that regular expression there, and then the refer has to be match this regular expressions, and if it doesn't, we serve an error with the text "no hot linking, please." Now again, if you try to we have never actually thought about hot linking at all, and suddenly Varnish had hot linking support or be able to control hot linking without us actually knowing what hot linking is. So, and that's quite cool. And also, if you if I go back to the configuration style of Varnish, if you can sort of imagine how a feature like hot linking would be described in a key value sort of configuration language, it would be quite bad, because I mean you have to allow it for some objects, and some other objects you can't allow it, and I know it becomes really messy. Okay, more about generically about Varnish. Varnish is what's called fully manageable. It has a powerful CLI with quite a simple protocol, which means that it starts up, and then it has a telnet. You can telnet into it, and then you can reconfigure it on the fly. And if you want to do that within your application, it's quite simple to do. Okay, so another sort of programming challenge. Okay. I see I switched places on those two slides. This is why Varnish is programmable. It's a state machine. Most of you are programmers, so you know what a state machine is. So requests in Varnish, they come through and they go through various states. We have the states here where we receive it, and then we sort of make a judgment if it's a hit or a miss. And if is it a cache miss, then we go here, and then we fetch it, and then we deliver it. And at each state here, we can run user code. So we can have your code, your sort of business logic, running at each one of these states. So if you want to do something after you fetched the object from the backend and sort of inspect it and maybe discard it if you don't like it. I mean, I've had a lot of screwed up app servers coming with an empty body. And so no errors, nothing, just an empty body. And we can test for things like that after we fetched the document. And if it is empty, we can try to refetch it. And then the dotted path here are the sort of the usual way you can jump. So you can also kind of, after you fetch the object, you can restart the whole transaction and start processing the requests anew. Okay, so here's the caching challenge. Okay, we have some new sites decided to switch to a paywall. And typically, this would be a new site owned by Rupert Murdoch, like the Times or the New York Times or something. Which means that only authenticated and unauthorized users can get the actual content. Now, this is a typical we can't cache this scenario. Because, I mean, there's authentication and authorization. So, I mean, you have to check stuff against the database. And the cache, which does not at all talk to the database, can't do that. So, the solution is buy more servers, write faster code. Or we can try to solve it in Varnish. And I can sort of give you an outline how this can be solved in Varnish. Now, we have the internet here. So we have, let's say for the let's call this the Times. So there's a reader there which has gotten a link to some article on the Times. So he sends a request, and the request hits Varnish. Now Varnish has a look at the request and see that this user hasn't got a session. There's no session cookie here. Okay. So kind of first thing, if we want this whole authentication and authorization thing to work, we need to have some sort of session. So we send the user to a login server. The login server displays some sort of login page. The user logs in. Credentials are checked against the database. And then we do a cryptographic signature on the actual cookie here, this part. We set the user ID, and we set the expiry, and then we set a cryptographic signature. Now then we issue some sort of a refresh. So the user tries one more time to actually get the actual article. Now, when this request now hits Varnish, it will hit it with the cookie set. And because Varnish has access to the actual shared secret, we can actually verify that the cookie is originating from us. So we know that this user actually is supposed to have access. And then we sort of end up just either getting the content from the web content management system, or if it's a cache hit, we serve it from cache. Now, this allows you to and if we're actually able to set this session cookie with a fairly short lifespan. So if we set the validity for maybe 4 hours, and then at some point we can sort of recognize the situation after 5 hours where the user comes along and he has a valid session cookie, but the session cookie is expired. And then we can transparently just direct him to the login server. The login server can then check against the database without having to supply the credentials that the user account is still valid. And then do a transparent refresh, and the user gets a new cookie, which is valid for another 4 hours. And he can go and have a look at the content. Now, having this sort of really short time to live is especially important for those of you in the porn industry where user accounts get invalidated all the time. Okay, there's a bunch of other features there. I won't really go into them into detail. I'm going to talk a bit more about what's up for the Varnish project next. Now, I think video is one thing we're going to see a lot of. As you might have noticed, HTTP has killed off just about any other transport protocol for video that there is. And Varnish can cache any HTTP-based stream. So we're currently working with a big American cable company, and they're doing scalability testing. They have a back-end system running Microsoft Silverlight, or the Silverlight smooth streaming video thingy. And we were able to push 3,000 concurrent users on each server with a 3 megabit H.264 streams. I have no idea what the native performance of Internet Information Server is, but yeah, I'm guessing it's not anywhere near. That's 8 gigabits of content pushed per second per server. So this is one thing I think we're going to see a lot of in the future. Also, as I mentioned, we have a release scheduled in 3 weeks. And maybe one of the major features there is module support. So the module it makes it easy to sort of extend VCL. VCL, I haven't mentioned it, is the configuration language of Varnish. So we have a domain-specific programming language, which is with these policies are defined in, and you can now extend that language in wood modules. It allows for reusable components, and it's rather simple to write. I think we did a blog post on just pointing out that we can now write modules, and I think it took 2 days. And somebody did a module, so you can now fetch content from Redis, the NoSQL database Apache project, directly in Varnish. And I talked to the guy, and he told me it took from he started reading the documentation until he had a runnable running module that integrated Varnish with Redis. It took 3 hours. Now he himself told me he's an awesome C programmer, so he might. I promise to warn people that it might take a bit more time if you're not an awesome C programmer. The modules are hot pluggable, as everything is in Varnish. So I mean, you can plug in the module while Varnish is running. So, somewhat of a recapitulation. We're caching a HTTP proxy. It has this configurable state machine that's configured with a domain-specific language, and we're not a one-trick pony. It is usually deployed mostly in the front end. We see a lot of people also, as people have a more and more complex and HTTP-based architecture, we see a lot of people deploying Varnish in the back end. When Facebook started using Varnish a couple of years ago, they used it to accelerate a lot of their internal services. So they have they had at that point they had a measly 100,000 servers, but still you have to do some data lookups on the servers, and just those amount of traffic internally on the administration side was enough to make them have scalability problems on the back end. So they started using Varnish there on the back end before actually pushing front end traffic. So, and kind of Varnish is, the cool thing about Varnish is that it supports HTTP, and HTTP is the mother of all protocols, more or less now. I mean, there's not one thing that doesn't speak HTTP. Considering buying this, weight, for measuring your weight, and it speaks HTTP. Yeah. And there's 2 links there, which for readability are light gray on white. Those are varnishcache.org. That's the project site where you can find more information about Varnish. There is varnish-software.com. That's where I work, and we do stuff with Varnish. That's my contact information. Please feel free to get in touch with me. I don't know if you have any time for questions.
Yes, 1 or 2 minutes if anybody has a question. Om någon har en fråga, vi kanske kan ta den på svenska.
Det kan vi gott. Det kan gott vara irrelevanta spörsmål då.
Där har vi en fråga där borta. Ja, vi hade en här också, men då börjar vi där. Visst, du var ju nära.
Hej. Finns det någon möjlighet att Varnish kommer få SSL-stöd?
Ja. Altså, jeg må si litt mer om det der, fordi litt av hemmeligheten til at Varnish går så fort som det den gjør, fordi den bruker mye veldig moderne operativsystemkall, så når den skal skrive til nettverket, så lar den operativsystemet skrive til nettverket. Så hvis vi skal dytte igjennom dette, vi har sett på en del SSL-bibliotek, OpenSSL og sånn, og bortsett fra at de har en horribel lisens, så er de også forferdelig elendig, altså det er veldig kompleks kode. Jeg tror OpenSSL-biblioteket er 10 ganger større enn Varnish. Så måten vi kommer til å få SSL-støtte på, blir en egen prosess som kommer til å kjøre foran Varnish, som gjør SSL-biten. Litt sånn som en proxy, men prøve å ikke miste så mye informasjon. For i praksis, altså, Der å implementere SSL vanskelig, fordi du har masse privilegert informasjon, og så skal du da prøve å skjerme den privilegerte informasjonen internt i prosessen, og det veldig, veldig kompleks. Så vi må dytte ut, og Varnish litt som designet som en hummer, altså det et hardt skall utenpå, så det mykt inni. Så det vanskelig å på en måte skjerme SSL-nøklene på en ordentlig måte internt i Varnish. Og derfor må den ut av prosessen. Det kommer til å ha en liten performance impact, men ikke så mye.
Jag har en fråga till där borta, sen får vi...
Ja, hej, jag heter Niklas Albert. Hur jämför du med Traffic Server?
Traffic Server jo et helt nytt prosjekt som vi ikke har egentlig sett så veldig mye til. Traffic Server jo gamle Inktomi sin løsning, som Yahoo har open sourcet. Altså for meg så i dag, altså jeg synes fortsatt at VCL, altså måten Varnish konfigureres på, det at du kan lage disse policyene, som gjør at du kan lage en policy for iPhone-brukere fra Stockholm. iPhone-brukere fra Stockholm, de skal få content på denne måten. iPhone-brukere fra Linköping, de skal få content på en annen måte. Den fleksibiliteten der sånn, den vil du ikke få noe annet sted. Og det på en måte ikke sant, når vi hadde en website som ble som noen jeg vet om ble angrepet av Anonymous. Og det som kult med Anonymous at de har en IRC-kanal hvor du kan gå og se hva som skjer, ikke sant? Så ideen da var det å prøve å sette opp et forsvar mot angrepet fra Anonymous, og så kunne man gå og se på IRC-kanalen og se hvordan de responderer på det. Det var kjempegøy. Men det de gjorde feil, fordi jeg tror denne low orbit ion cannon, jeg tror den sender en specific user agent, eller i hvert fall det et mønster i forespørslene den sender, som gjør at i og med at vi kan da i VCL så kunne vi da få Varnish til å kjenne igjen forespørslene, og i stedet for å svare på dem så kan vi bare diskarde dem. Det gjør at Varnish kan da håndtere inngående kanskje 1 gigabit med trafikk. Og i og med at mesteparten av de som kjørte low orbit ion cannon har ADSL og veldig begrenset upstream, så var det ikke noe problem å håndtere angrepet deres. Dere må ikke skrive det noe sted fra. Det et helvete.
Men i det fallet så kunde Varnish även fungera som en sorts DDoS-stoppare.
Ja, og ikke fordi den lagd for å være det, men fordi den fleksibel.
Tack så mycket Per. Då ber vi Ragnar att komma fram och utföra det ceremoniella överlämnandet av skiftnyckeln.
Du kallade mig för en tabloidbloggare. Så jag antar att du har läst vår blogg på loadimpact.com eftersom du var så träffsäker. Så.
Jeg gleder meg til å få den her gjennom security på flyplassen.
Ja, lycka till. Bra, tack så mycket Per. Tack så mycket.